this is going to be the attacker's browser. It's Firefox. Normally these would be on two different machines, right? But I'm going to have both the victim as well as the attacker on the same machine for now. So what I'll do is I'll start my tool. Okay, this is Shell of the Future. Okay, so it has two components. It's got a server and a proxy. By default, the proxy descends on port 1337, right? So we're going to start it. Right, start it. And this is started on the attacker's machine, right? So the attacker goes to his browser. He has to configure his proxy here to 1337 because that's the. Okay, the script has been injected now, right? If you go to infected, well, you can actually see that it is, talking to 127.0.0.1, and it's polling. So it's basically talking to Shell of the Future, right? So now, if I come here on the attacker's machine, you can actually see that there's a session available for hijacking, right? If you click on this, and this is the victim session, right? So now what I do is I say, I search for ABCD, right? If you actually go here, so you just, okay, one second. Okay, so you can actually see that the victim was searching for ABCD, right? So that request was sent by the attacker. That is sent to the victim's browser. The victim's browser fetches the page, sends it back to the attacker's browser, and so this is basically the victim session, and I'm accessing it from the victim's browser, right? So any conventional session hijacking countermeasures like HTTP only cookie or binding the session ID to the IP address is not going to work, right? You can still hijack the session, and this is probably the easiest way to do a session hijacking as well, right? So you're just comfortably browsing it in your own browser, right? And so that's how easy it actually becomes, right? So you can probably hijack as many sessions as you want. The more browsers you inject JavaScript in, it will show up as many sessions. You just click on hijack session and you can browse the session. Right, so this was reverse web shells with HTML5. Any questions on this?
So you have this open source or posted in
Oh, this is available on my website, Attack and Defense Labs, and the source code is available as well. If you want to go through it, you can. Okay, so we're done with that. Any other questions? And then I'll go on to the next section.
Can you do the injected script?
Oh yes, I can. In fact, this is available on the site as well. You can take a look at it. It's a very simple script. What I'm doing is I'm creating a script element, and I'm saying the script source is e1.js, and e1.js is the default exploit that comes with attack console, which comes with Shell of the Future, right? That's what is doing the polling and all that. So and then I basically add this element to the page. So I'm basically injecting a new script element to the page. That's what's happening. Right, any other questions? Yes?
Well, I've seen a project called Shell of the Future on a site called Internode. Is it the same one?
Internode?
Yeah.
It was basically this, he had written an article about this on his website.
Yeah. Oh.
This was released about 2.5-3 months back. Okay, so I guess that was Shell of the Future. So then I'll move on to the next section, which is clickjacking with HTML5. Right? Anybody here know what clickjacking is, or have actually tried to discover clickjacking vulnerabilities on your company's website when you do a pen test? Okay, cool. So you are the smart one, right? So clickjacking was a vulnerability which was discovered 2 years back. It's a very old vulnerability. It's been around for a very long time, but it came into focus 2 years back when Arsenic and Jeremy Grossman, spoke about it at OWASP, I think Asia. Okay, so I'm not going to explain what clickjacking actually is, but I'll talk about a different kind of clickjacking. Normally in a clickjacking attack, what usually happens is you get the victim to click on a page or on a link or on a button, right, of a target page without him actually knowing about it, right? And traditionally, what people think is clickjacking attacks are limited because you can only get somebody to click on a link, or you can only get them to click on a page, right? But you cannot do anything more. Say, for example, if I want somebody to fill a form for me, right, I cannot get them to do that using regular clickjacking. So because of that, people usually try to underrate, the impact of clickjacking. But using HTML5, you can get somebody to fill a form, right, and then you can get them to click on the link. So it's almost like a bypass of your CSRF countermeasures, right? So even if you have a CSRF token in your website, you can still get someone to perform a CSRF attack, right? The only thing is it requires user interaction, but that can be done using a little bit of social engineering, right? So the way, and to fill forms across domains, right? The API that I'm going to use is the drag and drop API, which is a part of HTML5, right? So using drag and drop, the API is actually pretty simple. It lets you drag one object and drop it onto another part of the page, right? And the thing with drag and drop is you can drag an object from one domain and drop it onto another domain, right? So cross-domain drag and drop is also possible. And the interesting thing about drag and drop is when you actually drop an when you actually drop an object onto a text field, you can say what data must be filled into the text field, right? So this is how you do it. Let's say you create a div element, and there's an attribute called as an on drag start, right? And you will say set data, and then I'm saying evil data, right? So when somebody is trying to drag this element, the data that will be set when they drag it onto a text field will be evil data, right? So I can set any value that I want here, and when somebody drags it onto another domain, a text field in another domain, that data is going to be filled into that, into the text field, and after that, when the user clicks submit, right? So that form is going to be filled with the attacker's data. So to explain it, I've made a simple demo. Hopefully that will help you understand it much better. Okay, so this is a demo where it says, put the fish in the bowl, right? So this is a harmless looking demo. What's the harm? You just want to help the fish. So you drag it, you put it into the bowl, right? So what you don't see is an iframe, which is actually set to transparency of 100%. So I'm going to make the iframe visible. So what you actually see is the Google search page, right? And it already has some text filled into it. So this is some attacker controlled text. So when I drag the fish and I put it on the bowl, I was actually filling in this particular field in google.com. So just so that you can see how it happens, what I'll do is I'll set it to visible, and then I'll do the drag and drop, right? So you can actually see that it's getting filled. So this way you can fill text. You can fill fields across domains. And as far as the user is concerned, he is just helping a fish. He doesn't even know what he's doing, right? So imagine, for example, this was not the Google search page, but this was your account settings for your mail, probably, right? In your mail, you normally have a password, or you have a secondary email, so you can get somebody to update the secondary email, with your email ID, without them actually knowing about it. And once you update the secondary email, it's almost as good as you having access to their email account, right? So that's how dangerous clickjacking actually is, and it is something that you should actually test for, right? And HTML5 just makes it even more dangerous because you can now fill in forms. Okay, so this was filling forms using drag and drop API. There's another bit to clickjacking with HTML5 again. It's called as iframe sandboxing, right? Usually the countermeasure for clickjacking is to include something called as frame bursting, right? Frame bursting has been, even if you refer OWASP, it tells you that frame bursting is not the actual, is probably not the best way to approach it. There are ways in which frame bursting can be circumvented. So there are a couple of things which OWASP recommends that is done to prevent clickjacking. But folks generally tend to go with frame bursting because that's probably the easiest way to implement a countermeasure. There are about 3 ways in which frame bursting can be disabled. One of them, probably the simplest of them, is using something called as sandbox iframe. Right? HTML5 introduces a new attribute for iframes. Right? It's called as a sandbox attribute. So anytime you include a page in an iframe, it's going to execute script within that particular iframe. But if, say for example, you're going to include an untested page and you don't want that page to execute script, so what you can do is you can set the sandbox attribute. And once you set the sandbox attribute, JavaScript is disabled specifically for that iframe, right? So HTML, like this, was actually introduced as a security feature, to actually prevent malicious iframes from executing script. But it can be used in the wrong way, because now when you disable script for this page, you're also disabling the frame bursting code, right? So frame bursting never happens when you include a page in this type of iframe. So I've got a demo for this as well. Show you real quick. Okay, so this page, if I give an URL and if I say frame this, it's going to add it to the to the frame down below. So what I'll do is I'll try to include PayPal in an iframe, and PayPal implements frame bursting, right, for clickjacking defense. So I'm saying frame this. Alright. So PayPal loaded in the iframe, and then the frame bursting code executed. So it came out of the iframe, and now PayPal is like the primary site on this domain, right? So this is the clickjacking countermeasure which they have put in. Now I'll do the same thing again, but this time what I'll do is I'll set the iframe to a sandbox iframe, right? Right. So, and it got loaded and it stays within the iframe, right? The frame bursting code is not working anymore. The downside to this is, since JavaScript is disabled, some of the features of PayPal might not actually work, right? But there could still be some features which would not require JavaScript, which could be exploited by an attacker. Right. So that was clickjacking with HTML5. Any questions on that? No. Alright, cool. So I'll go on to the next HTML5 cache poisoning. I guess I'll probably skip over this. It's really not that important. We don't have too much of time. Okay. Now I'll talk about client-side remote file inclusion. Right. RFI is usually considered to be a server-side thing. You could have client-side remote file includes as well. We'll just see how that happens. Alright. If you do a lot of web browsing, which I'm sure all of you actually do, you might have seen websites URLs like these. You have the domain name, right, and then you have hash followed by some URL, right, followed by the name of the page. And if you click anywhere on the page, you will see that the URL remains the same. The only part that changes is the one after the hash, right? So this is a relatively newer type of site design, and the way this works is, they've got a bit of JavaScript on their page which goes like this, right? So anytime a link is clicked, what happens is a new HTTP, a new AJAX request is sent for the URL which is part of this section is called as location.hash, right? So the page takes whatever URL you provide here, it fetches the page, and then it adds the output to a div element, right? So basically it's like fetching the page and it is adding it to your div element. So basically you can browse the whole site by staying in just one page, and whatever URL you give here, that is fetched and added to the page, right? So you see any problems with this kind of an approach?